All right, good morning. My name is Michael LaBa. I am a partner at Southeast Engineers and I'm the manager of House Tips. Um, House Tips is a new educational forum that I've established on the internet and in CEU classes where we're out trying to educate builders and home inspectors and homeowners and folks about their houses, excuse me, how things behave or misbehave is really the goal. So I have about 24 years in the residential industry from an engineering background. I am a licensed engineer and focused on residential properties. I'm a former home inspector, or designer, I'm a forensic engineer, look at about 250 buildings a year. So that's the background of which I'm coming in to give some of these presentations. So I'd ask everybody to silence your phones, just check them, put them on vibrate or quiet or what have you. Thanks.
You're nice. I just usually call them out.
Yeah, there you go. So today's agenda is rather brief, but I want to kind of convey some thoughts that we see. When I say we, I want to introduce Gordon McDowell. Gordon is my colleague who helps me in the forensic engineering world. So, but back to the agenda, we're going to talk about some of the characteristics of raised foundations and give you some examples of common raised foundations, pier and beam, if you will. And some of the failure mechanisms that we see that I want to kind of introduce to you guys so that you can be aware of connections and assemblies and so forth and so on. Got some kind of extreme cases and then some milder cases that I want to present to you. These are things that we see when folks, quite frankly, have problems in their buildings, whether it's brand new, literally brand new, or 30, 40, 50 years old, okay? It's the new ones that really hurt because we've been in some of these newer open floor plans where the load paths are breached and literally see 2 inches of deflection in a brand new building. So today we're going to focus on foundations and, oh, here we go. Whoa, going the wrong way. So we're going to talk about some load applications and management. I want to talk about soil compaction, the preparation before we really get started with it. Some footing plans and some attention to detail. These two segments here, this is where I'm going to introduce at least these concerns, and I don't really talk about it that much more, but in the attention to detail for your foundation, I'd suggest, and I don't know if you do or don't, this is just from my end of things, really look at chasing some of the dimensions when you start getting into your form work, laying out piers, if you're going to have a cladding on your pier or some arrangement or accommodation, gutters, those types of things. Try to follow those dimensional details to make the accommodations. When we see misses, we have brick veneer overhanging foundations or gutters coming right down on foundations or spread footings. That tends to channel water back beneath the house. Those kinds of things which create some long-term systemic issues. So I guess my point of emphasis here is to just check those dimensions and follow your load path right from the roof right through all the way down into the foundation and into the spread footing. So check during the installation, check the plumbness of the piers and the piles. Really, piles left long when they're canted create a real problem when you start bringing the frame assembly into the foundation. We've literally seen some of the beam assemblies start on the inside on one pile and at the next pile be on the outside. So I don't really know the full process of keeping those piles plumbed, but anyway, a point of emphasis. So, and then the last thing is plate and bolt and rebar installation tolerances. That's where I would look at the details. If you're a plan designer, house designer, architect, whoever it may be, just check those details and make sure your bolts line up. I was looking at a building 2 weeks ago where the hurricane straps were misaligned. I'll use that term. They literally have slack in the strap as it ties from the foundation into the frame. So in a high wind event, you've got all the play in that anchor. Those are the kind of things that I'm talking about. I'm a little trigger happy here. Oops. Let's talk about load applications. This is a simple diagram. If you attended some of my other classes, this is very consistent, but it's a point I want to bring up. So for us to get to the reactions here in our raised foundations, we need to look at what's contributing to this foundation circumstance. This is just a detail I pulled off of one of our plans just for emphasis. So I think we are all aware that on the building assembly, according to code, we have live loads and dead loads, right? I'm not going to get too far into that, but the live loads are when people move across floor systems and what have you, or in your attic and so forth. The other thing that I feel like is missed commonly in design and in construction, so it's easy to beat up on contractors, but we go through plans. Gordon is architect trained and a former building official, plan official. So we see where the breaches in the design occur, and they occur a lot. And then the real concern is that contractors make assumptions and continue with the project. So they're, in my opinion, assuming liability. But back to this point, when the wind is applied to a building, as we've depicted it here, it is resisted in two ways. One is lateral, which is going to be the ability of the foundation to hold the building assembly in place. So that keeps the building from sliding when the wind is blowing in this fashion here. The other, more important circumstance is if you fix this corner of the building in the foundation, with the wind blowing this way, it wants to create a moment and, overturn the building. Very rare. In hurricanes, those things happen. We have some examples of that here. But you need to get a sense of those are the types of forces that are acting on the building. So it's going to be putting a lot of pressure on the far side of the wind forces. Can you understand what I'm trying to say here? And we'll show you some examples when that system fails. Now, these reaction loads are related to soil pressure, and we'll talk about that in just a second, which is going to get back to soil compaction, a circumstance that I want to learn from you guys about how that gets accomplished on your projects.